The second example asks us to evaluate. When we are evaluating, that means our answer will be a number. Now, we are evaluating an integral here. It is a definite integral because it has terminals, in this case 0 and 1. So your answer must be a number. That number could be a negative number, it could be 0, or it could be a positive number. Also remember, in specialist maths, all answers are to be exact answers unless otherwise told. So, the first thing we have to do is look at the integral and recognize which one of the inverse circular function formulas to use. In this case, it's going to be inverse sine. We have the integral from 0 to 1 of 1 on the square root of 4, which is 2 squared, minus x squared dx. This tells us that a is equal to 2. So, anti-deriving, so we write the square brackets. Inside we write the antiderivative using the formula inverse sine of x on 2. Remember, there is no plus c when you're working out definite integrals, and we close our square brackets. We write the terminals on those square brackets, 0 and 1. Now we substitute in. The first thing we do is we substitute in the number that is on top of the square bracket, which is the 1. Then we substitute the number which is lower on the square bracket, which is 0. The other thing to remember is we subtract the two answers you get. The answer when you substitute in 1 and the answer when you substitute in 0. In this case, the substitution will only result in one term, so we can subtract those two terms. But be careful on other problems where there is more than one term. So, substituting in the 1, we get inverse sine of 1 on 2 minus, substituting in the 0, inverse sine of 0. Inverse sine of a half is pi on 6, minus inverse sine of 0 is 0. Pi on 6 minus 0 is pi on 6. There is our answer. It is an exact answer. Do not work out a decimal approximation of it. All answers that have pi in it are exact answers.